Hello and welcome to this video on why what you see with the setting sun is at least in part a lie. When you see this image, you may believe the sun is not yet set. The problem with that is the human eyes can be easily deceived. This means when you think the sun is set, it actually happened long before. The sun and earth are far apart, and what we observe from our place on the ground is often difficult to get right. This is a result of the way we see things. Imagine what a ship at sea far away looks like. Depending on where you are in relation to it, your ideas may vary. The curvature of the earth is a big factor in that. When you look at our own watery globe, the atmosphere is another consideration. This mixture of gases can be a source of distortion for anything beyond Earth, especially light. Together, these 2 points are why the sun sets well before you think it does. Let's set the stage. You are here on Earth and looking directly out to the horizon. The sun is here and moves to here as it sets. This lets you see the light as it travels in a straight line. Here if it is uninhibited. Of course, for that to be the case, you are not on Earth as there is no atmosphere. This atmospheric effect is important as it is a variable we need to account for. When we start to look at the setting sun, it's a different size, and this should be the first giveaway that something's odd. The sun appears larger on the horizon than when it's higher in the sky. This is despite the fact that the sun should be a constant size, and its distance away from Earth shouldn't really affect our perception of that. The first thing to be aware of is that the human perception of objects closer to the horizon means they appear larger than they actually are. Next we have the angle of the sun as it's setting. As you watch the sun set, there's going to be a horizon, and this horizon sits at an angle that is, theoretically, at roughly the same plane as you, but in reality, due to the curvature of the Earth, is slightly lower. This means that as you watch the light coming from the sun, it passes through a larger section of the atmosphere. This leads the light to being affected by both refractive and scattering effects. The refraction is going to make the bottom part of the sun, which is what you think has hit the horizon, appear higher than it actually is. This is why the sun appears to be substantially further up than it is, and why the sun sets earlier than you think. Near the horizon itself, you get scattering of shorter wavelengths of light. This is again affected by the atmosphere, and it passes through a much larger portion of it. The atmosphere in this case affects the blue and green wavelengths more than the others. As yellow, orange, and red wavelengths are longer, they wind up being less affected by the atmospheric molecules, and why the sunset appears to have a reddish color. This all creates a curious effect. Where this looks like sunset, it is in fact quite late. The sun is just as far below the horizon as you think it is when it has set. To get the timing right, roughly, you need to pick the time when the sun is approximately its own diameter above the horizon. This is a somewhat curious and fortuitous but random coincidence. The reason is simple. The combination of refraction and distortion means that while you think the sun is here, it is actually here, and as said, long since set. Combination of curvature of the Earth and the atmosphere all come into play. And for those who believe in a flat Earth theory, this alone should help to disprove the notion. Thank you for watching this video. If you found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions that you have below.